is a number theory question from SMO 2019 Round 2. For this question, we ask to find all positive integer mn such that these two expressions are both integers. We can separate into two cases. Case 1, m equals to n. If m equals to n, then both of them actually the same. And 2m minus 1 over n equals to 2m minus 1 over m. Let me just write as 2n minus 1 over n, and this is equals to 2 minus 1 over n. Now note that this is an integer. If this is an integer, then n has to be equal to plus or minus 1. But because n is a positive integer, then we can only choose n to be positive 1. So in this case, m and n both the same, and they must be equal to 1 and 1. So for case 1, m equals to n, this is the conclusion. We'll go to case 2, where m is greater than n. And for the case m less than n, it is symmetry. So we need to consider only m greater than n. So case 2, m greater than n. Now note that if m is greater than 2n, then 1 over 2n will be greater than 1 over m. And 2n minus 1 over 2n will be greater than 2n minus 1 over m. And this obviously is less than 1. Note that since m and n are positive integer, then 2n minus 1 over m is positive. If m is greater than 2n, then it means that this expression is in between 0 and 1. It is not possible to be an integer. Combine these two cases, then we know that m has to be greater than n, but at the same time less than 2n. This means that 1 over m will be then 1 over 2n and less than 1 over n, and therefore 2n minus 1 will be in between these two numbers. And this is equal to 1 minus 1 over n, and this is 2 minus 1 over n. Since n is positive, then it means that 2n minus 1 will be in between 0 and 2. And therefore, has to be equals to 1, which means that m is equal to 2n minus 1. For this case, if m is greater than n, then we conclude that m has to be equal to 2n minus 1. Now let me continue here. So if m is equal to 2n minus 1, then we know that this term will be equal to 1. However, for this term, 2m minus 1 over n will be equal to 2 of 2n minus 1 over n. And this is 4n, so it is 4 minus 3 over n. And this is an integer. And therefore, n has to be equal to 1 or 3. In the previous case, we know that when n equals to 1, m is equal to 1. And therefore, in this case, n has to be equal to 3. If n equals to 3, then m from here will be equal to 5. And therefore, mn is equal to 5, 3. So to conclude, the value of mn will be equal to 1, 1, 5, 3. Since it's symmetry, 5, 3 is the answer, 3, 5 will be also another answer. And these are all possible cases for the value of mn. We can change the question a little bit. You may try it, and you can check your answer in the description. So this is the end of today's lesson. I'll see you again. Bye-bye.